Hi guys, my name is Philip English and I'm a robotics enthusiast reporting on the latest business and applications of robotics and automation. My mission is to get you robot optimized to support industry, infrastructure and innovation for the next era. Today we have Herbert Tenhaver from Fizyr, who's going to give us an overview of Fizyr, and we're going to fire a few questions at him just to see how the business runs and what solutions that he has. So hi there, Herbert.
Good afternoon.
Afternoon. So I suppose to start with, could you give us like an overview of yourself and your company?
Sure. I'm 57, still alive. You can breathe and you can do all kind of active stuff. I run a company called Fizyr, which is a spin-off of the university by a professor. He had an academic view of the world and having robots to do all kinds of jobs, and put a brilliant team together. And now we also have a business plan, and we are in quite good operation. A few years ago, we won the Amazon Picking Challenge, both stowing and picking, and that's the moment we stopped doing robotics. No more robots.
Okay. So you've moved from the hardware to the software side.
The brain. Actually, what we're doing is like self-driving cars. We translate the image, what the camera sees, into where the robot should move. Right. And that's why also our new name, Fizyr, means scope. We look through where it should be grasped, as well as we look in the future, new applications and new technology.
Wow. Okay. And Fizyr means scope. Oh, okay.
Yep. Dutch and German and Danish, it's all scope. It's
all the same. And obviously, I saw the bit about you won the Amazon Awards, and that was because of your deep learning capability of the software.
Correct.
Right. Yeah. So, how big's your team then, from like a size-wise?
24 currently.
Right, I see. And then obviously, so you've come from a university background, so I guess you've got a quite like an academic source of inspiration there, which is something that's really interesting. I mean, so what's the main problem that Fizyr is solving?
Okay, good question. So let's take a parcel in e-fulfillment, like this envelope. Yep. Every time you drop it, the robot will see a different envelope. It will always be different. Or take this towel, it will always be different. So there is no way you can program it. You program a robot, how will it look like? Because it will always be different. So the only way to sort of recognize it and classify it is to generalize, to teach it to generalize like we humans can. Like a kid of 1 year old can see that this is a box and can grasp it. And so what we've done, we trained a neural network with a lot of images, so supervised learning. So we teach them, this is an envelope, this is a box, etc., and millions of images. And at some point, it became good at doing the same thing as humans, understanding that this is a box, a bottle, a tube, a cylinder, etc., and to pick it from a bulk of unknown parcels.
Right, I see. So obviously, the main problem is that from a normal vision system, it's hard for it to distinguish where one item ends and another one starts. So within your software, it's obviously got a lot of deep learning tools that actually does that distinction. And I suppose the main problem for the customers is that if they can't find where the product is, they can't get a robot to pick it up, and then they can't move into an automation type of process to speed up the process. So,
correct. Yeah.
Okay, that makes sense. And then, so in regards to the actual camera system, then, I mean, is it one type of camera, or is it any camera that you can use and you put your software on top, or?
Yeah, no, we are hardware agnostic, both on the sensor, the camera side, as well as on the robot and the end effector, the gripper. Yep. But having said that, we mostly use RGB depth data. RGB as being what we see right now, and the depth image is to do triangulation. So we need to know what is the distance. So for that, you need a depth camera, which is a stereo camera, with in the middle is structured light, like a flashlight, with different ways of structuring it. And based on that, that camera will create a point cloud from which you can derive the distance and to see how it's positioned. So, for instance, take this box. This time you would here attach suction to simulate it. vacuum. In this case, you have 2 sides, but we will see maximum 3 sides of each parcel. So we will find those places where to grasp with the robot to simulate the item.
Right, I see. So that's the mechanics of how it works. And I suppose, would it, could you, if you had 2 cameras or 3 cameras or 4 cameras, does that add on and make it more and more of a product the products you can see, or was it just 1 camera and that's all you need?
As always, it depends. The key thing is the camera should see it. If the camera cannot see it, then the algorithm, the neural network, cannot see it. So the good exercise is normally when we want to pick something, we look into the bin and we can find what we want, but we are flexible with our eyes and we can move. But so assume you have the camera above, then you just look at the screen and can you see it in the screen? And then we can train the neural network to pick it as well. So we've had many applications that the neural network was much better than human beings. So for us, it was too hard, but the neural network was more faster, accurate, and more robust.
Right. And would it make sense? I mean, is it just an example there? Obviously, if a camera's I only got 1 position, would it help to have maybe a system where the camera was almost moving to some degree to help like pick it up?
Not necessarily. In most cases, we pick, let's say, from a pallet or from a bin or from a conveyor. And as long as it's visible for that camera, and then the robot can move there as well. Because what you can see in the camera, then the robot can move at the same direction as well. Because it's free. There is no other objects in between.
Right, perfect. And then, so to give us some examples, I mean, like, where have you installed this type of technology?
Okay, one of the nice things, and we'll show you in an image, is picking the corners of towels.
Okay.
And that's really hard. So towels are in bulk, white on white, for instance, and you have soft corners, like when it's bended, but you also have the hard corner of a towel. And what the algorithm does is finds the corners of towel, and then picks it, and then feeds it into a folding machine. And then the towel is folded. So that's something that has been in operation for a few years. So we started doing that. And now we are mostly in logistics. In e-commerce, it's item picking. So picking unknown items which you order online, as well as when the item is being packaged into a bag or a box. We have to pick the parcels also from bulk for, let's say, DHL, UPS, Federal Express, etc. And we do also truck unloading and depalletizing, which is mostly also boxes, let's say.
Right, and for the truck unloading then, so the idea is obviously the back of the truck pulls out, then I suppose a bit of a challenger question, like where would you put the camera? Does the camera sort of drop down to the back of the truck so it sees in and then pops up again?
Now, first of all, we don't build the machine. We only are the brains that translate the image into. But what they do is they have a camera on the device that goes into the truck. So, and there is a robot picking each of the items and putting it on a retractable conveyor. So the items, the boxes or bags are singulated from bulk, from unknown. And I will show you the image as well. And then put on a conveyor, and then it's being handled in the warehouse.
Right, that makes sense, yeah, because I understand in big like logistic houses, you would have a device that goes into the actual lorry with a conveyor belt on, and then obviously the items can be picked. Yeah. I mean, in regards to the towel folding, I was having a look at that Foldymate robot. I'm not sure if you've seen that. It's like it's like a house appliance. I think it's on Kickstarter right at the moment.
In our case, it's a really professional robot. It's been there for a while. It's really for the professional laundry industry. So in hotels and conference centers and a lot of laundry when they have 3 shifts per day dealing with laundry.
Yeah, I've been into some of those sites myself, and it's a 24-hour operation of just washing and washing and washing. So yeah, I can see the advantages.
Humid and warm. So it's something at some point we realized we should not do this as humans.
Yes.
So we should just sleep at night and have robots doing the work for us.
Yeah, no, definitely. Yeah, that's definitely the way. I mean, in regards to the robustness, because obviously I was saying that's one of your key features. I suppose the first question, can you use it outside? I know you wouldn't normally have a robot set up outside, but can you have cold and snow and wet, or would it still?
Yeah, for the software, it doesn't matter, of course. Okay. So it's all about, do you have a camera that's IP waterproof and all the stuff, and most, I would say, 95% of our applications are indoor, but some of them are like truck unloading, could be outdoor as well.
Right, and then I saw I was reading up. So the scanning can scan up. Is it like 100 items a second?
Yes, correct.
Yeah. So if the robot was fast enough, I mean, you could really,
there is no robot on Earth that fast. No. So the neural network is extremely fast. So we use a GPU, like in an NVIDIA card, where we play with. So we use that to do that process. So it's extremely fast in providing all information, including the grasp poses of the unknown parcels. Yeah.
Yeah, because I was reading that. I was saying, that's really fast. I was thinking, you would need a lot of robots, or attacking. So I suppose then, as you're saying, like, the bigger picture then is really for those sort of dull, dirty, and dangerous jobs. That we have robots with the Fizyr system that can obviously pick the items and do the job for us. I mean, what's your sort of like future plan? I mean, I did see from your website, obviously you guys have very successfully like bootstrapped up to 2020, and I think you've recently got some investment. So you'll see expansion is on your mind. So
yeah, we're quite unique. I think in Europe, bootstrapping is more common than to get some investment. So we revalidated our product with our clients. So we have clients like Toyota. For 4 years already. So it's really, we go into a long-term relationship and we build things, go in production, and then we build the next one. So it's the Americans would go faster and etc. But we would like to get everything in order and then go to the next one. So that's how we build up. So now we have the product ready and we can scale easier. We are in logistics, which is, like I said, e-fulfillment and parcel handling, and we do something in airports as well, but it has not been disclosed. It's always logistics, and in 9 out of 10 cases, it's either a box or a bag.
Yeah, that's right. I've been into a lot of airports as well, and I've seen them deploy some robotic systems in there. So I suppose that'd be a perfect target for you really, because just making sure different sizes of luggage and bags. Make sure, because that's key. If you go on holiday, you want to make sure that your luggage is there.
Yeah. But like I said, we only deal with the computer vision part. So there are 2 more elements to it. Secondly, do you have an end effector, a gripper that can cope with the variation? So if I have to pick up a pen with suction, I need a very small suction cup to pick up this one. When I have a bigger box, let's say would be heavy, then I need multiple suction to grasp it. So it's do you have a gripper, an end effector that can cope with the variation that can be expected? That's the second challenge. And the third one is all about the integration. So how fast can you accelerate or decelerate without throwing it away? So how well do you know it's attached? Is it safe for the environment, for people? Do you have a cobot or an industrial robot? So integration with the warehouse system. So there are a lot of things around it. So there are 3 phases, and we tackle the first phase. Can you see it? Do you have perception? Do you know where to grasp?
Right, I see. Yeah, no, that makes sense. I mean, I did see your gripper as well, and have you made that like open source, so anyone can sort of build their own? Is that the idea, or or use your technology?
Yeah, we do a lot of open source. So if you go on GitHub and Fizyr, then you will see a lot of RayTranet and other stuff that we made open source. So we have a lot of followers. We're very proud of that. And it also brings in new developers. So we get a lot of developers through the open source community, because they know us. So the gripper is something we give away designs as well, because we only do software. We don't do hardware. We don't want to do. We just want to stay digital. And so it's a really nice market. It's so big, and there's so many challenges still to go. It's not as easy as it looks, because in warehousing, if you go to a sorting center, it looks like a war zone. So you'll see everything, car tires, all kinds of stuff is being shipped. So it's not easy, and they're working hard, and so there is a lot to be done still.
Yes, yeah, no, that's very true. I mean, I've been into a lot of those sites as well, and I can definitely see that there's that you need a good vision system to make sure that you pick up the right items. I mean, just going back to the gripper though, I mean, there's so obviously that's open source. So then I was going to ask a payload question, but I suppose it depends on how you build the gripper or how they would build the gripper, like using your technology.
Philip, the payload is very simple. You have a vacuum.
Yeah.
And you have a surface, so you can just calculate what is the maximum force you can apply. So in order to lift something with a certain amount of vacuum and surface, so you can calculate, and if it's well touched, then you can grasp it. But let's say if it's something like this, like a towel, the air will go through.
Ah, right.
So you need to take that in account, and then you need to apply more flux. So like a vacuum cleaner, you can still pick it up, as long as it's not going to be sucked in. So you need a filter. But so our neural network knows what it is, can classify it, and knows in some cases you have to apply more air. More flux in order to grasp this, and so you can also measure how much air goes through, how well it's attached, in order to know how fast you can move without throwing it away.
Right, and I've seen recently there's a lot more of those soft type of robotics that have all sorts of arms and flux that make it even more useful for those types of operations. So
the key thing is the combination between what the robot sees, the information, the eye-hand coordination. So the more, like we humans, we have flexible hands, we can do a lot. So the same applies for the robot. You can have a smart gripper with multiple suction cups. So we can apply based on, if it's this one, we only use this suction cup. So we can apply different suction cups, different size and shapes, based on the material we're going to grasp. And so then what we also do is stacking.
Okay.
It's like playing Tetris.
Okay.
So we pick something of unknown, and we look what are the dimensions, and we look into the place where we want to play the unknown place, like a pallet or a bag, like groceries. We do micro fulfillment, and then we place the item in the unknown environment.
Right, so you got the ability to do that as well. So I was speaking to a friend about you guys. So he's got a project to do with waste recycling. So as you can imagine, massive plant, lots of all sorts of rubbish sort of coming along a conveyor belt, and I know he's looking into a technique to do it, and I think they're actually saying, "Oh, look, we only need it to work 30% of the time, and then we can work on it." I mean, have you guys had a chance to have a play with that industry yet? Or
yes, we did 3.5 years ago.
Okay.
And then we decided we want to focus on logistics, because it's logistics like a blue ocean. It's so big, and we claim still think we are the best in the world. Although we are small, and we want to stay the best. So you need to focus. Yeah. And just stick with that one, and just be and stay the best, because you can do a lot of stuff, and it's really interesting. It's nice to do, but at the end you need to stay the best and just to focus. It's hard
on the main area. Yeah. Okay, no, it's great. So I mean, what's the latest news? Like, what's the next thing for you guys are looking into?
It's helping our integrators, our robotic integrators worldwide. So now our software is in production in the US, North America, in Europe, of course, and in Asia, China, and soon Japan. But what we see a lot is in e-fulfillment that they will have micro-fulfillment centers. Okay. So one of our clients is, for instance, Fabric. They have micro-fulfillment center to bring the groceries really towards the homes. And they are in cities. So that's really a robotized, like lights, they call it lights out factory, where everything is done with robots. And I would say we're still ahead of that. There will still take maybe 1 or 2 years, but that's definitely what the industry is going for. To have lights out factories where just truck comes in, it's unloaded, and the robots take over the rest.
Right, and then your software, like either lights on or lights off, can still do the same job.
We need some light, but the lights off means, let's say, no people or just remote. But again, we only do a small part. We only do like self-driving cars, where to drive. We are for the robots, where to pick. That's the key thing we do.
Yeah, and I suppose you would expect on a lights out factory, you know, on certain items that need light, then it would flash on a light, so it can do its job like most efficiently. So yeah.
Yeah, in our case, we always need light. We need RGB and so we need light to see. But lights out as a term means that they can have a factory without humans around, and so they call it lights out factory. So, but in sorting center, everybody buys a lot online, and the number of parcels only increases every year. So that's a big challenge in the industry to be automated, because there's a shortage of humans doing this work, and we don't like to do it in the middle of the night or weekends working on the depalletizing or picking parcels. So we should have robots doing that.
Yes, no, I totally agree. I totally agree. Have you had any work in hospitals or sort of medical care? There seems to be a lot of speak about that, robots coming into the hospital world. I mean, I suppose you using your software to organise certain items around the hospital. Have you guys had any traction with that? Or
focus, logistics, and the only thing that we still do is picking towels, and sometimes that's in a hospital as well. But we really want to do focus, and we do pick medicine. By the way, it's e-fulfillment, so picking small boxes of medicine and blisters and stuff. It's part of it.
Right, fantastic. Okay, no, that's great, Herbert. I think we've got a great overview of Fizyr. I mean, what's the best way to get hold of you then?
Well, you can follow us on LinkedIn. We post frequently, let's say a few times a week. Of course, follow us open source if you're into developments. I'm online, so you can reach me if I can help you. More than welcome to help you.
Great than that, and I suppose that could be a mixture of end users, integrators, and anyone who needs that the vision to basically move items around then. So there's a big industry there.
Sure, but I meant also personally, if a student has a question or whatever, working in the Netherlands, we have 11 nationalities. We have a lot of people from abroad. We have consent to hire people from abroad. So we're always open for new brilliant talent joining us.
Brilliant. Thank you. Okay, Herbert. No, that's great. Many thanks for your time today. It's very much appreciated. Thank you.
Thank you. It was my pleasure. Take care.